Alright, so this is a video on what are similar polygons and how to prove it. So what are similar polygons? They're figures that have congruent corresponding angles and proportional sides. So with these two triangles, angle A is the exact same measurement as angle D. You can see by the congruent marks for those two angles. Angle B is congruent to angle E, as you can see by the double congruent marks that you know they match. Angle C, therefore, is congruent to angle F. That's the first half of the definition of similar polygons. They also must have proportional sides. That means that when you create ratios of corresponding segments, that they have the same fraction when you reduce. As an example, CA and FD are corresponding sides. That means as a fraction, 16 over 12, if I reduce that by 4, I would have 4 over 3. For these triangles to be similar, every segment has to create 4 over 3. So when I go to AB over DF, I'd have 20 over 15. If I reduce this by 5, I get 4 over 3. I go to the last segment that we have for the triangles, CB over FE. That's 24 over 18. When I reduce that by 6, that's 4 over 3. So these two triangles are similar because the corresponding angles are congruent and the sides are proportional. Alright, so this problem wants us to determine if the two polygons are similar and explain why. So for these to be similar, they have to have corresponding congruent angles, and their sides need to be proportional, which means they have to have the same similarity ratio from one figure to the next on all the sides. So if we look, we can see some angle degrees. This right here is an angle degree of 120. So since we have parallel lines, that means this right here is going to be 60 degrees because these two angles have to add up to 180. So if this is 120, then the other angle is 60. That goes around the whole figure. So from here to here, these two angles should add up to 180. So this is 60, therefore this is 120. Same thing for the other one. This is 60, this is 120. So we can see all the corresponding sides, corresponding angles are congruent. So their angles are all working out nicely. We just have to check to see if their similarity ratios are the same. So 10 to 15 reduce is 2 over 3. 14 to 21, reduce it by 7, you get 2 over 3. 10 over 15, once again, gets us that 2 over 3. And 14 over 21 gets us 2 over 3. These polygons are similar. They all create the same similarity ratio, and their corresponding angles were congruent. If you look at this one, once again, we'll determine if these two polygons are similar. So down here, the angle is 55. Up here, the angle is 35. Once again, these two need to add up to 180 degrees. This angle and this angle here. So this is 125. This angle corresponds to this one. They're not the same angle measure, so therefore these are not similar. If the corresponding angles are not congruent, then the figures are not similar no matter what else is going on in the picture. We're going to prove these two triangles are similar by using our shortcuts. To do that, we're going to use the name to figure out what sides of the triangle correspond to each other. So CD corresponds to FG. And we're going to create a similarity ratio with those. So we're going to write 81 over 36. We're going to reduce the fraction by 9, so we get 9 over 4. Then we can use the name once again. DE is going to match up with GH. And we're going to create another ratio there. So 90 over 40. We can reduce this by 10, making 9 over 4. And then the last one we can see is going to be EC matches up with HF. So 72 over 32. We can divide this by 8, and we will get 9 over 4. Since all the sides have the same similarity ratio, these two triangles are similar by side, side, side. Okay, so for this one, we have some information about sides and an angle. So we can easily see that angle R and angle H are congruent. So since we have an angle that's congruent, that's between two side lengths with measurements, it's likely SAS, but we got to prove it. We got to make sure we create similarity ratios. So we can see by looking at the picture that RQ corresponds to HG. So we're going to create a ratio there. So 55 over 10. If we reduce that by 5, we're going to get 11 over 2. When we make our other ratio, we need to get an 11 over 2. So you can see 65 over 12, 65 over 12. If I try to reduce the 12 so I would get a 2 in the denominator, I would have to divide by 6. So dividing both sides by 6, 65 divided by 6 is 10.8. So we do not have similarity ratios that are the same for both our sides. Therefore, these two triangles are not similar. These two fractions would need to be the same to make this similar figures. Okay, for these two triangles, we can see that angle here and here, which would be angle WRQ, is congruent to angle WUV. When you're looking at the triangle, there's actually two of them. There's this smaller triangle here and the larger triangle. Well, they both share angle W. So we know that angle W is congruent to angle W, which fits the theorem AA. So we know these two triangles are similar because of angle, angle.